control laboratory for the experiment too, for the title on off and proportional integral derivative PID controller. So I will show for the first part experiment for the on off controller. So this is the block diagram. First, this is the desired temperature. I will set at the final value 85 Celsius, and this is the on off controller at switching point at 3 and switching off at -3. So the initial temperature is set at 30 and the output will be shown on the scope and to the workspace. So when I run the programs, I will get this graph. The yellow is the desired temperatures set points at 35 and the blue is the output. So I'll also use another switching point value at 1 and switching off value at -1. Second is the switching point at 6 and switching off point at -6. Based on the result, the effects of the neutral zone and on-off controller performance, the higher range value switching on-off controller around the set point value, the higher of the percentage based on the settling times. Okay, next we continue to the part A for the P controller. So this is the PID controller for block diagrams. But in this experiment for P controller, we only use the proportional gain. Another than KP, we just insert 0 and 0. So the temperature set point is set at 60 Celsius final value, and the initial temperature is 28. So when we run, we get the output at the scope, and the yellow is the level set points and the blue is the output. We also use a different value for the proportional gains at 0.0009 and 0.003. So based on the result, the effect of proportional gain P controller performance, the P controller primary function is to reduce the system steady state error. The steady state error of the system decrease as the proportional gain factor KP increase.
Assalamualaikum and hi, my name is IZZATI ZAINOL, DEY 0079. So I would like to present for part B, PI controller. So first thing first, we will change the derivative gain into 0, and then we will change the proportional gain into 0.00216. Okay, and for integral gain, we change the value to 0.0000432, and then run. Select scope for the output, and then we get the graph we need. So we need to repeat procedure for another value. So we need to change the integral gain into 0.00000632 and run again for another output. And the step is repeated for another value. Run again. You can see that the graph is a bit lower than the previous one. That's all. Thank you. The next part is PID controller. So for PID controller, we will need to change the value for each gain. And then for proportional gain, is same. Secondly, for integral gain, the value is changed to 0.000096. Okay. And then for derivative gain, we will use 0.2175. And then run. So this is the graph for the first value. And then we need to repeat the procedure. The derivative k is changed to 0.5. Okay, and then run again. This is the output for 0.5 derivative gain. And the procedure is repeated again. The derivative gain is changed to 0.0575. And okay. So the step is run. This is the final output for the final value. Thank you.
Assalamualaikum and salam sejahtera. My name is Mohammad Farhan. So I will explain for part D, lab 2 MKS for PID controller tuning. For this part, we need to tune and adjust the proportional gain KP, integral gain KI, and derivative gain of the PID controller in procedure 5.3.3 to achieve following specification. For following specification, we need pen setting time is TS is under 2700 seconds and percentage is overshoot under than 30%. So here we can see I'm using proportional gain 0.003. Therefore, integral gain I'm using 0.00009, and for derivative I will be using 0.05. The lowest derivative is more stable for the system. And then we click on and then we click scope, and then this is the graph. We got Cmax is 74 and set point is 65. So we got the settling time here is 2400, and for overshoot percentage, if we use this CMAX 74 minus by 65 divide by 70 divide by 65 and then time by 100, we will get is 13.846%. So we can see here that we achieve the following specification, that is the settling time is under 2700 and percentage of overshoot is under 30%. That's all for me. Thank you.